Hi and welcome to the Mathemagic channel. Today we cover another worksheet on modular arithmetic. So these questions are a little bit harder, very interesting. Let's try it out. And so we start this worksheet finding the modulo 6 residues of each of the following. And so mod 6 residue is how much do we have left after a multiple of 6. So if we look at question A, 13, well, we know that 12 is 0 mod 6. If you're not too sure about modular arithmetic, please look back at the first video we made about modular arithmetic so that you can familiarize yourself with it. So 13 is one more than a multiple of 6. So if you remember how we count, we go 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0. So 13 is going to be a 1 because it's just one more than a multiple of 6. So we're going to call this congruent to 1. Now 53 is 1 less than 54. 54 is 9 times 6, so 54 is a 0. So we could say that 53 is negative 1 mod 6. But negative 1 is also 5. So negative 1 and 5 are the same thing. So you can use negative numbers with modular arithmetic. 84 is pretty interesting. It's not obvious that 84 is in the 6's times tables. If you're not sure that it is, understand the divisibility rules for multiples of 6. And so in order for a number to be a multiple of 6, it has to be divisible by 3 and it has to be divisible by 2. And so those two conditions will make it a multiple of 6. So in order to be divisible by 2, well, that's pretty easy. A number needs to be even. 84 is even, so that's okay. To be a multiple of 3, we look at the digital sum. So when you add the digits, and you can do this, you can say 8 plus 4, you get 12. And when 8 plus 4 is equal to 12, the sum of the digits, what we call the digital sum, it means that it's in the 3's times tables. So whenever you add the digits and they add up to a multiple of 3, then it's in the 3's times tables. So 84 is in the 3's times tables and it's divisible by 2, therefore it's divisible by 6. And in being divisible by 6, we can say that 84 is actually a 0 mod 6. So 184. 184, we could try and use the same technique that we did just now, but we could also realize that 184 is actually equal to 180 plus 4. And 180 is going to be a 0, so we can say that this is a 0 plus 4, which is just a 4 mod 6. So this is good. 63 plus 91. 63 is 3 more than 60, which is 3. So we can say this is congruent to a 3. And then 91. 90 is going to be 6 times 15. So 91 is 1 more than a multiple of 6. So we can say this is 3 plus 1, which is 4. 141 minus 78. Well, 141 is a multiple of 3 because 1 plus 4 plus 1 is 6. So it's in the 3's times tables, but it's not even. So what we can say is that 141 is 3 more than 138. And 138 is even and a multiple of 3. So we can say it's 3 because it's 3 more than 138. And 78, 7 plus 8 is 15. 78 is also even. 78 is a 0 mod 6. It's in the 6's times tables. So this is going to be a 3. Okay, 519. 5 plus 1 plus 9. 6 plus 9, that's 15, right? So that's in the 3's times tables, but not in the 6's times tables. So we can say it's 3 more than 516, and 516 would be a 0, so this is a 3. So this is a 3, and then 444 is a multiple of 6, because 4 plus 4 plus 4 is 12, and it's even, so we can say it's a 0. And 37 is 1 more than 36. 36 is 6 squared, so that's plus 1. So we can say that this is congruent to a 4 mod 6. Okay, for question H, you might not even need to go through modular arithmetic here. You could say 12 minus 11 is 1, plus 10 minus 9, which is another 1, plus 8 minus 7, which is another 1, and this is going to be congruent to 3 mod 6. Moving on to the questions on the right here. So 43 is a 1 because 42 is a multiple of 6. It's 6 times 7. 32 is 2 more than 30, and so this is going to be the same as saying that this is 1 times 2. And 1 times 2 is equal to 2. Okay, 59 times 159. So we know that 59 is 1 less than 60, so we can say negative 1. And then 159, 159. 1 plus 5 is 6. 6 plus 9 is 15. So that's a multiple of 3. So we can say 156 is a multiple of 6. So 156 is a 0. So this will be a 3 here. So we can do -1 times 3, which is the same as -3. Okay, moving on to 14 to the power 6. Now this might seem a little bit difficult here, but with modular arithmetic it's not too bad. So 14 is not a multiple of 6, but it's the same as a 2. So you could say that this is the same as 2 to the power 6, mod 6. So 12 is a 0, so 14 is a 2. 2 to the power 6 is 64. So we could go through that. We can say that this is equal to 64, and 64 is congruent to a 4 mod 6. So that works. Let's try this question here. 101 to the power 99. So 101, well, 101 is 102 is a multiple of 3 that's even. So we can say that 102 is a 0. So if 102 is a 0, 101 is going to be congruent to -1 to the power 99 mod 6. And a negative number to an odd power is a negative number. So this is -1. And -1 is the same thing as, so we can write it here. -1 is going to be the same thing as 5 mod 6. So make sure that we don't confuse all these answers together. So this is a 5 mod 6. So if you were to do 101 to the power 99 on your calculator, the last digit would be a 5. Now your calculator is not able to do that because it's only going to give you the first 8, 10, or 12 digits. And there's so many digits you won't be able to know. So you can't actually do this question on a calculator, but you can do it using modular arithmetic, which is pretty incredible. Okay, to verify if this is true here, we're going to talk in mod 8. So we have some questions here that we can do. So 177 and 17. Well, 177 we can say is congruent to 17 mod 8 because it's 160 plus 17. And 160 is going to be a 0. So 160 is going to be a 0, and so this is congruent to 17, and therefore 17 is congruent to 17 mod 8. Actually, both of the sides are a 1. 17 is a 1, and 177 is a 1. Okay, 871 mod 29. Now this looks really intimidating. So what we can do here is we can think of multiples of 29. So I'll just list them up here for you. So we've got 29. 29 times 2 is 58. And then 58 plus 29 is going to be 67, 87. So we've got like some multiples of 29, which we can use here. So if we look at those multiples here, we think that 87 is pretty good because you could say that this is 870 plus 1, which is going to be congruent to a 1 because 870 is going to be a multiple of 29, which is a 0. And then for the other side, we can say 713. We could take away 580. So let's do 713 minus 580, which is going to give us, so 3 minus 0 is 0. 1 we can borrow, so we do 11 minus 8 is 3. And then we change this into a 6. 6 minus 5 is 1. So we got 130. So we can say that we have a remainder of 130 here. So we can say this is congruent to 130. And if we want to take out a bunch of 29s out of this, that's a little bit awkward. Maybe we need the next multiples. So 87 plus 29. What's 87 plus 29? We get 96. And 96 plus 20 is going to be 116. So it looks like 116 is a multiple of 29. And if we add another 29 to this, that's too big. So we can do 130 minus 116. And we're left with 14. So you can see that the left-hand side is 1 mod 29, and the right-hand side is 14 mod 29. So the first question is true, the second question is not true. They're not congruent. Okay, we'll need to make a little bit of space to do the next questions. Question C here, mod 12. So a good idea is to think that 13 to 2 is the same as 1200 plus 122, and 1200 is a 0, so we can say this is congruent to 122, and then 122 you can take away 120, so you can say this is congruent to 2. 120 is 12 times 10. So that's for the left-hand side. For the right-hand side, so this was the left-hand side. So for the right-hand side, we can say 5294 is the same as 4,800. So 4,800 would be a 0 because it's 4 times 1,200 plus 494. And then we can change the 494 into 480 plus 14. So we can say this is congruent to 480 plus 14, so 14. And 14 mod 12 is going to be a 2. So therefore, this one is going to be correct. 5141, let's do this one first. So 5141 would be nice to take out a big multiple of 11. We can take out 4,400 maybe. So if we say that this is 4,400 plus 741, so the 4,400 is going to be a 0. 741, maybe we can take out 660. So we can say this is 660 plus, so this is going to be a multiple of 11. So 741, we're 81 away. So we can say this, and then here we can say this is the same as 77 plus 4, and so this is congruent to 4 mod 11. And for the right-hand side, so if we do the right-hand side, we can say 8353, that's congruent to, so what do we have? 7,700 plus 653. Now we can take out the 7,700. 653, we can take out 550, which leaves us with 103. And from 103, we can take out 99. And if we take out 99, we can say that this is congruent to a 4. So this is going to work. And in this case, we have 4 mod 11 on both sides. 13944, super awkward. Again, I would advise you to start with your 13s times tables here. So you'll get 13, 26, 39, and then 39, 52, like in a deck of cards, 52, then 65, that's 5 13s, then we have 78, then we have 91, that's 7 13s. That should be enough to keep us going. So we can start with 13944 and change it to 13,000 plus 944. So then we can say this is the same as 944. Now 944, the closest one is going to be 910 because it's 91 times 10. So we can say this is congruent to 34. And then 34, we can take away 26. So we're left with 8 mod 13. So that's good for that one. And for 8919, so 8919, so 89, we can say 78. We can start with 78. So we can say 7,800, which leaves us with 1, 1. Is that right? 1, 9. Let me just double check. 7,800 plus 1, 1, 1, 9. That seems good. And here we can take out, well, can we do 91? What's the next one after 91? 91 plus 13 is going to be 104, right? Can we take out 1040? Yes, we can. So we're going to take out 1040. I might do this subtraction here just to make sure I don't make a mistake. 1119 minus 1040 is going to be a 9. Then there's a borrow here, so we have a 7. Then this becomes a 0. So 0 minus 0 is 0, so 79. So we're going to say that this is congruent to 79. 79, and then we have a 78 up there, so we can say that this is congruent to a 1. And I guess that is not correct then. These two are not congruent, mod 13. For the last few questions, mod 8, question G is pretty straightforward. We can say that 17 is a 1, 18 is a 2, 19 is a 3, and then 20 is a 4, and that is definitely congruent to 4 factorial when we're in mod 8, so this is definitely good. And for our last question, we're mod 17, so again, I would encourage you to have your multiples of 17 ready. Now, one thing that you could do to go a little bit faster here is you could realize 17 times 5 is 85, and the way that I do that is I divide 17 by 2. When I want to multiply by 5, I divide the number by 2. So 17 times 5 will be 8.5 times 10, and that's 85. And then you'll notice that 83 is congruent to -2 mod 17, right? So these are this is a pretty convenient relationship. And for the right-hand side, 15 is 2 less than 17, so it's congruent to -2 as well, mod 17. So therefore, you'll have -2 to the power 144 congruent to -2 to the power 144. And regardless of what that is, they're going to be congruent. Okay, we're done with those questions. I hope that was useful. Now remember that those Math Olympiad problems can be really dicey when you do a Math Olympiad or a Caribou or any kind of contest that has a little bit of competition math included in it. And modular arithmetic is one of those skills that you can use whenever you're asked to find the last digit in the division of a number by, say, 7 or by 13 or by 10. Or if you're asked to find the last 2 digits or the last digit in a certain division. So always think about modular arithmetic when you have those kind of problems. Now this worksheet was very, very good for you to familiarize yourself with that kind of work. I hope this was useful. See you on the next video. Please like and subscribe to the Mathemagic channel to help us. We really appreciate your support. Thanks for being here today. See you on the next one. Keep practicing your mathematics.